Good morning, students. Welcome to our mathematics class. Today, our lesson is about division of radicals. The learning competency for this topic is performs operations on radical expressions, and the learning objective is perform division of radicals. Okay, carefully analyze the examples below. Let us follow the rule. To divide radicals of the same order, use the property the nth root of A over the nth root of B, and it's equal to the nth root of A over B. Then rationalize the denominator. Example number 1, square root of 3 over the square root of 5. This will be equal to square root of 3 times 5 over 5 times 5. Then it is equal to the square root of 15 over 25. Okay, we're doing this because when you multiply 3 and 5, our product is 15. And also multiplying 5 by 5, the product is 25. Okay, we're going to find the square root of 15 over 25. So remember that our denominator is 25 and this is a perfect square number. Therefore, the next step will be square root of 15 over 5, because square root of 25 is equal to 5, and this will be our final answer. Okay, proceed to example number 2. The given is a cube root of 5 over cube root of 2, and this is equal to a cube root of 5 over 2 multiplied by 2 squared over 2 squared. So we're going to rationalize the denominator. Then we have the cube root of 5 times 4 over 2 cubed. Okay, the simplest form of 2 squared is 4 over 2 cubed, the product of 2 and 2 squared. Then after that, simplifying, we have the cube root of 20 over 2, because 2 times 4 is 20, and then the cube root of 2 cubed is 2, or simply cancel the index and exponent of the denominator. And this is our final answer. Okay, to divide radicals of different orders, it is necessary to express them as radicals of the same order, then rationalize the denominator. Example number 3, our given is a cube root of 3 over square root of 3. So in different orders, so we have 3 for the index and then 2 for the index of the denominator. So since the index they are different, therefore we're going to do is to transform to exponential form both the numerator and the denominator. So we have 3 raised to 1/3 over 3 raised to 1/2. And then note that our exponents are dissimilar fractions, so we're going to find the LCD. Then we have 3 raised to 2 over 6 over 3 raised to 3 over 6, because the least common multiple of 3 and 2 is 6. And then we're already done in transforming the dissimilar fraction to similar fraction, so we have the same denominator. Now it's about time to transform to radical form. Okay, why? Because in transforming this to radical form, the result we have the same index. It's about time to rationalize and follow the property. Okay, so we're going to follow the property. We have the 6th root of 3 squared over 3 cubed. So rationalize, multiply both numerator and denominator by 3 cubed. Okay, then next is we have the 6th root of 3 to the 5th over 3 raised to the 6th. Then we have to simplify 3 raised to the 5th. Then we are going to have the 6th root of 243 over 3. So this is our final answer for this part. Okay, next. To divide radicals with the denominator consisting of at least 2 terms, rationalize the denominator using its conjugate. A conjugate is inverse of the last term of a binomial. Let's say a minus b, the conjugate is a plus b. Example number 4, 3 over square root of 3 minus square root of 2. Okay, rationalize the denominator using its conjugate. Okay, now write the given. So we have 3 over square root of 3 minus 2. Then multiply by square root of 3 plus square root of 2 over square root of 3 plus square root of 2. Okay, take note, our middle symbol or sign is negative, so this will be positive because the conjugate of the denominator is square root of 3 plus square root of 2, and then rationalize. Then next step, use the distributive property for the numerator. So multiply 3 by this binomial, and also for our denominator, multiply binomials using a FOIL method. Okay, let's do it now. Then our answer for this is 3 square root of 3 plus 3 square root of 2, because 3 multiplied by square root of 3 is 3 square root of 3, and 3 times square root of 2, this is our answer, 3 square root of 2. And then over, using a FOIL method, so 3 times square root of 3 times square root of 3, we have square root of 9. And then square root of 3 times positive square root of 2, so we have plus square root of 6. For our second term, we have negative square root of 2 multiplied by positive square root of 3, so we have negative square root of 6. Then for the last, negative square root of 2 multiplied by positive square root of 2, our answer is negative or minus square root of 4. Okay, after that, we're going to use the additive inverse to combine like terms in this part. So the inverses is obviously the two middle terms. So plus square root of 6 and minus square root of 6. So cancelled. Then we have 3 square root of 3 plus 3 square root of 2. So rewrite the numerator there. And then find the square root of 9 and this negative square root of 4. So we have 3 minus 2. Then subtract. The result is 1, and 1 is invisible for the denominator. So our final answer is 3 square root of 3 plus 3 square root of 2. That is our final. Okay, we have the activity. Let's perform division of radicals and simplify the following expressions. Okay, number 1, 2, 3, 4, and 5. So I hope that you can find the correct answer for this activity. Okay, class, that's the end of our lesson for today. And thank you so much for watching.